各位贵宾、各位朋友，大家早安。非常感谢大家今天拨冗出席这场 By Aerospace 未来航空论坛。我们齐聚一堂，是为了共同关注电动飞机与未来航空的发展趋势。By Aerospace 目前全球领先的电动飞机的先驱，他们致力于推动永续、零排碳的飞行新时代。今天我们也特别邀请到 Empress Technology 的执行长孙刚博士担任翻译与协助引言。孙博士是国际科技产业的重量级企业家，当然也是我非常敬重的导师。那接下来我们将时间交给孙博士，请他为我们引介接下来的贵宾。
OK， 各位早上好。今天我请这位这个公司另外我的朋友到这儿来呢，给大家做个介绍。这个公司它主要是做电动的飞机，是可以载客2个载客或者4个 passenger 所以这种飞机呢，在这个世界上还是第一次这个技术也是这个世界上第一次。这原因我参与这个活动的主要原因是他们会用我们 Empress 的电池用 Empress 电池。那这公司的 CEO 是非常有经验，对飞机非常有经验的一位了。他曾经是F-16 战机的飞行员，在美国军方在这个飞行上面有多年的经验。然后几年前，待会儿他会介绍自己了，参与了这样的一个公司。所以电动飞机是有好几种的，有一种大概大家看过，就是有螺旋桨的那是一类的电动飞机。那还有一种电动飞机，我们叫 fixed wing 就是这个机翼它是固定的就这一类的飞机这一类的飞机在目前全电动的几乎没有他们如果能把它做成，他们大概是第一家。那还有一家叫 Hard Airspace。在瑞典，他们也在做，但他们现在几乎已经放弃了这个全电动的这样的一个概念，所以能把这个做成是很了不得。他们到这来有2个目的了，一个最重要的目的是想看看台湾有没有投资方愿意参与投资他们这个公司，第二呢，也想看看台湾有没有做电池包的公司，我们台湾也很多嘛，像新普啦、伟创啦这一系列的公司因为现在这个电池包是在美国做的，我们做电池，我们有一个合作厂商，他做这个 pack 那么如果我们在这边有台湾的投资方参与，另外我们又有台湾的投资方台湾的 pack 厂，甚至于做这个飞机的厂如果能在台湾做，把产业链摆在台湾，这也是他们的另外一个目的所以我下边就请这个公司的 CEO Mr. Rod Zastro 来给大家做个介绍。那 Rod。
Thank you, Dr. Kang. Dr. Kang, as you likely know, is the CEO of Amprius Technologies, the company that we consider to be the world's leading aviation battery manufacturer. I could not be more honored than to be introduced by him. I revere him as an aerospace colleague and business leader, and we're very honored that he has taken the effort to help us introduce the E-Flyer concept to you here. So thank you, sir, very much.
他就是说就介绍一下我了因为我们公司做的电池现在最重要的就是在这个航天航空所以美国的几乎所有的无人机。美国的所有的无人机都是用的就是有名的了但当然还有很多无人机厂我们不知道，用的都是我们的电池。现在欧洲最大的无人机公司用的电池也是我们的电池。美国的战机有一些这种当然不好很透露的一些战机侦察机用的电池也是我们的电池，所以我们希望我们的电池能够支持他们的这个飞机。
I also want to thank William Lin, who is walking around somewhere, and the staff for setting up today's event.
也感谢林先生举办这样的一个论坛。
And I want to thank each of you for taking time out of your very busy day to come here today. I hope to impart lots of information and make your time very worthwhile.
感谢各位这个花时间来参与这个论坛，希望你们得到这个有用的信息。
As Dr. Kang had said, my name is Rod Zastro. I am the CEO of Buy Aerospace Incorporated, a U.S. company based in Denver, Colorado.
我是这个公司的 CEO， 我讲就是他了，是这个公司的 CEO。公司是在美国的这个卡罗拉多州。
I am an aerospace engineer by education, and I spent 26 years in the United States Air Force.
以前就是在学校的时候学的就是这个航天航空，后来又在美国的空军服役过。
And as I believe Dr. Kang said, I flew F-15s for many of those years. I went through the Air Force version of the Top Gun school early in my career, flew in combat a number of times.
以前就是这个美军 F-16 战机的飞行员，然后也在几个美国的军事基地，包括冲绳都服役过。
I'm very excited to be back in what I consider to be my neighborhood, in the sense that I lived in Okinawa, Japan, for 3 years as my first command of an F-15 unit.
非常高兴又回到了这个冲绳这个附近。以前他这个第一次在海外服役就是在日本的冲绳。
Also in my military career, I was trained as a military strategist, and I became a specialist in Asian strategy for the U.S. Department of Defense, advising the Secretary of Defense in policy before I left to go into the commercial world.
在美国空军的时候，他主要负责这个战略部分，曾经做这个美国战略部部长的助理。
So for me, I feel very comfortable being here, having lived in the region, as well as understanding the region's strategy and the challenges we face, especially in the recent turbulence economically. But I'll have words on that a little bit later on how our company is actually not involved in those.
这次来到台湾感到很熟悉，因为对亚洲的这个战略以前有过研究和学习。这次回来就是希望我们这次回来不是从事这个军事方面的这个讨论呢，这次回来主要是看看能不能在商业上与台湾同行合作。
So let me turn my path to discussion to a little bit of history of Buy Aerospace. The company started as an engineering services firm in the 2000s.
这公司下边就介绍一下这个公司。公司最早的时候实际上是一个这个工程服务性的公司。
In the course of providing engineering services, the founder, Mr. George Buy, visited a Tesla factory where the idea came to him, if electric propulsion can be in automobiles and trucks, why can't they be in aviation?
在做这个工程服务的时候，这个公司的创始人，这个公司为什么叫这个 Buy Aerospace 呢？他以前那个创始人就叫 George Buy 所以就用他的这个姓定了这个公司。在那时候他就说，那么汽车既然汽车可以用电池来驱动，为什么飞机不可以用这个电池来驱动呢？
So he and the former Cessna aircraft president, who was part of the company at the time, they decided to modify a Cessna 172 with electric engine and batteries, and they proved it can be done, but realized they only had 15 minutes duration.
后来他们就把一个现有的飞机，把它用电池把这个油箱换成了电池，试飞了一下，但是当时的飞行这个距离只能飞15分钟。
So this point established the key difference between us and our competitors, and in that with the aircraft you see here, it's a clean sheet design, meaning we started from scratch. It is not a retrofit. It is the only aircraft design in the world that started with a clean sheet because we can gain from the cleaner aerodynamics of a much smaller front end of the aircraft that has a small electric engine. It has lightweight composites, and it has very sophisticated design engineering.
这个竞争对手的做法呢，就是把现有的飞机 在里边把这个它这个驱动的机制变成了电池。那么这个 By Aerospace 他们是从开始就设计啊，这个这个飞机是全新的啊，飞机的机壳的材料啊，里边的驱动的机制啊都是全新的，所以这个飞机它会轻了很多啊，它的续航能力也强了很多。
So the company flew the Cessna technology demonstrator. They flew a second, more of a glider type of powered glider technology demonstrator, and then modified a light sport aircraft as a proof of concept.
这公司现在目前已经设计了这个整个这个公司的整个这个飞机的外形，加上这个整个这个驱动系统都已经设计好了，已经做了这个最初步的这个设计呀。下边就是需要做一个样机。
The By Aerospace company was the leading company in the world at that time in all of these efforts and helped the U.S. regulatory agency called the Federal Aviation Administration, which I will refer to as the FAA. We helped them write the new rules that allowed for electric engines and batteries in aircraft.
他们这个公司同美国政府的合作是相当紧密的。实际上他们是帮助了这个美国政府这个验证机构啊，写了这个怎么验证的这样的一个这个程序啊，所以这个公司它在这个整个从现在到验证这个过程呢，也会是相当顺利。
So the United States adopted the first rules for electric aircraft in 2018, and our company was the first applicant under those new rules with this design.
2018年，美国政府出了这个新规定，就是说这个电动飞机的要求，从安全啊到整个这个飞机的设施啊，到飞机的认证，他们公司是第一个申请这个飞机认证的。
Unfortunately, in the time of COVID, where the FAA sent many of its workers to work from home, work slowed to a snail's pace. And the company essentially became a stranded venture company. Therefore, 2 years ago, as an investor and as a deposit holder of many of the E-Flyer aircraft myself, I was asked to take over the company last year at this time, and we have restarted the company.
这个在公司申请了这个认证之后这疫情就来了，所以说在几年疫情里边呢，公司有一些停摆的状态。在去年的时候呢，那 Rod 他就被这个公司的创始人邀请参与了这个公司的运行。
So as part of the restart, we have narrowed our focus from several type of aircraft designs to our first design, the E-Flyer 2, which is a two-seat aircraft designed predominantly for the training market.
他加入公司之后呢，等于这个公司又重新开始的话，首先的这个公司的聚焦呢，就在这架飞机，这个是个两个 passenger 两个乘客的一个训练机。
We also raised some funds so that we could start the actual construction, the fabrication of the first full-scale E-Flyer prototype, which we are now conducting, and we will show you a video of this later in the presentation at our headquarters in Denver, Colorado.
他们融资之后呢，就是设计了这个公司这个飞机的雏形待会儿呢会有一个这个 video 有个视频给大家看一看它这个飞机现在的这个情况。
So we have slashed our operating costs, we have changed our company focus and our culture, and we're excited for the future ahead. So with that, I will start the formal presentation.
刚才这个介绍了，就是说他加入了公司之后呢，他们公司有很多的行动，把公司的整个这个运行的结构啊、运行的风格都有了改变。下边他说他开始这个正式的介绍他的这个公司。我想这一段大家都可以看懂，要能看懂英文的话，我就不翻译了，翻译效果实际上不是很好，中间没有那个 dynamics， 所以they can read the English, so I'm not going to translate this It's part of it. Yeah, they can look at the slides.
Okay, very good.
Yeah, thanks.
Thank you. And so I am going to phrase my comments for both the potential investors we have visiting with us today, potential manufacturing partners, and potential clients such as flight schools, governments, and so on. So I will try to cover all of these topics in a broad sense. Beyond this presentation, we will be available this afternoon for one-on-one meetings and tomorrow until about 4 p.m. for additional one-on-one meetings if you'd so like. So our presentation starts with, the bottom line is that we are currently raising $50 million US that will complete the certification and the production ramp up for this E-Flyer 2 aircraft. The aircraft is fully designed. It has many of the FAA approvals, and we have many backlog aircraft, and we simply need to bring in the funds to complete the certification checklist items and start producing the aircraft. So with that in mind, what's important is that for this aircraft, the problem we're trying to solve is that, as you know, as you travel, more and more people are traveling. However, there are not enough pilots to fly all of us around. So there are many aircraft that are parked, many aircraft that are not flying because we simply don't have enough pilots to fly those aircraft. And the Boeing, CAE, and Airbus forecasts tell us that we need 28,000 new pilots this year, and 10 years every year we need 30,000, and in 20 years from now we need 32,000. So the problem is only going to grow. We have about 3,400 flight schools around the world that fly approximately 18,000 to 22,000 training aircraft. Unfortunately, those training aircraft are on an average 45 to 50 years old. That's hard to fathom. It's hard to imagine. But in the training aviation industry, the very smart and skilled mechanics replace the engines every 2 to 3 years and refurbish the aircraft, which is very different than how we take care of our automobiles and our trucks. But this is the norm in the industry. But those aircraft are getting very old. So to train the 28 to 32,000 new pilots every year, the industry needs to produce approximately 2,000 to 2,500 new training aircraft every year going forward. And this I have worked with McKinsey & Company, a globally known advisory firm, and they agree with us on this. However, the current industry production is not 2,000 to 2,500. It's only 550 to 700. This is Cirrus, Piper, Cessna, and Diamond. Together, they only produce 550 to 700 aircraft per year, which means there's a 1,500 aircraft shortfall every year, and it's getting bigger. And the other part of the problem is that training is very expensive, and so 80% of all student pilots who start, they stop. They stop because it's too expensive. The average cost of a Cessna 172, just the operating cost for every hour, is $160 US. That's very, very expensive. That is 4 times more than when I was learning how to fly, which was more than a few years ago, but even adjusted for inflation, that's extraordinarily high for many reasons. So there's a huge, clearly defined market and a sustained underserved market that we think it will be underserved for the next 20 years at least. A huge opportunity for us. So we designed our aircraft with that training market in mind so that we could solve the problem of too few aircraft and too expensive to fly aircraft. This aircraft, as it's designed, the principal reason and benefit to all of our prospective customers is that we can lower the operating costs by up to 80%. And that's done by not using aviation fuel or oil, by reducing the maintenance requirements through its simple design, by 2/3 to 3/4 of the maintenance costs are reduced. And there are other reduced costs. They're not having to refurbish the engine every 2 to 3 years. So this aircraft is designed, as you can see in the graphic, to also make it so that it can fly to meet the mission times of the training flight schools. The average flight for a training mission is approximately 1.3 to 1.5 hours. Because of our clean sheet design, lightweight composites, and advanced technology batteries, we are able to forecast that this aircraft will fly approximately 2 hours in terms of a mission going to the training airspace, doing maneuvers, coming back and doing touch and go patterns or practice landings and takeoffs. It is the only aircraft in the world designed to have this type of duration to meet flight schools. We know this because battery companies, not just Dr. Kang, but others come to us saying, we'd like to work with you because the other designs that they're working with are all retrofit designs that are either made of metal aircraft that are very heavy, or they are retrofit without changing the aerodynamics or other reasons, and none of them can meet the flight training school requirements. Beyond this, because I come from the flight training industry, I know their needs very, very well. Part of my history I didn't talk about was that once I left the US Air Force, I helped a company called Spartan Education Corporation. They are one of the world's leading pilot and maintenance training organizations. And I helped them with a first ever US government foreign military sale where I went and lived in Iraq and set up a flight, pilot, maintenance, and English training school north of Baghdad. So I've personally run flight schools and I know these problems firsthand. So with this aircraft, we know that those aircraft need 1.3 to 1.5 hours, and this aircraft can do it with 80% reduced operating costs. The operating cost per hour, unlike the Cessna 172, which I learned to fly on a 172, I loved the airplane, but it's time for a new generation of aircraft. And this aircraft, we forecast that it will only require $35 per hour to operate it. So this is a drastic change and a disruptive innovation that can be brought to the flight training industry. This industry is highly regulated, as I've mentioned, through the FAA in the United States, what's called EASA, EASA in Europe, and Transport Canada, and each country has its own licensing and certification pathway. We are the first ever applicants for electric propulsion in this category of aircraft. We have all of our designs accepted by the FAA. We have what's called the functional hazard analysis, which is the safety plan on how does this aircraft handle all of the things that can go wrong in flight. That is addressed and been accepted by the FAA. And our test program to reach certification has also been accepted by the FAA. So we have our certification checklist, which is really a compliance checklist. This is to where we have accomplished a significant amount by helping the FAA change the policy to allow electric aircraft. We've accomplished all of the steps necessary for certification, except for the actual building of the aircraft and flying it to meet the standards that we had agreed with the FAA. So that's why we are raising funds, is to raise the funds to be able to bring on, to build up the team, to build 3 flying test vehicles and other test articles and the tooling, and that helps us get to that certification as well as beyond into the manufacturing. So while we have a clear market, we have a clear path to certification, and we have a design that we think is going to disrupt the market, you don't have to take my word for it. You can take the word of many, many flight schools and individuals who have brought us a 3-year backlog of over 1,000 aircraft, of which 45% are paid non-refundable deposits. Those are firm deposits. And together with letters of intent, that represents $700 million of backlog, which we believe is a historical precedent for an aircraft category of this size. We also know from working with the flight schools, we had the United States' second or third largest flight school visit us, and the head of their flight school said, "We have seen all of the electric training aircraft programs. We think yours is the best by far." We have gotten tremendous feedback from the market, so we believe we have that complete solution. To attain that solution and reward investors, and as well as our partners who work with us, we need to have a leadership team that comes from the market, understands certification, understands how to build companies, and how to perform. And we have that between the brilliance of our founder, Mr. George Bai, on the right, Mr. George Dunn, our lead fundraiser and CFO, in the middle, and he's the individual whose contact information I provided on the first and the last slide. And then for myself, having come from the industry and having started a greenfield project with Spartan College, they provided the former CEO and myself $1 million, and we turned that into a $1 billion foreign military sale of historic proportion that had never been done for the U.S. Department of Defense. So I've had the extreme pleasure and honor to start a company from scratch and build it, and what I learned along the way, it's all about finding the right people, the right talent who are motivated to join in that team to execute the plan and the strategy for success. So we have that now. We've spent a year rebuilding, restarting this company. We have an action plan. We have a plan on not only how to build an aircraft, but also how to manufacture it and get it in the hands of the flight schools that desperately need it. Turning to the aircraft itself, I won't go through all the specific details, but I would say it fits in a normal category of flight training type of aircraft. You see from the design, it's for two people. It's a wider cockpit, so it's a little more room. We have taken the engineering design criterion and put those into a flight simulator model called X-Plane, for those who might know that in the aviation industry. And it performs as good or better than expected, and we believe it will have better performance than some of the legacy aircraft, and will be right-sized for the training industry. What's very important to flight schools is that they want to be able to operate our aircraft as frequently as the current aircraft. And we can assure them of that because our charging time, because of the batteries and pouches and the capabilities that Dr. Kang and the industry can do now, we are able to charge these aircraft after a typical training mission in only 20 to 30 minutes. We do not need 5-minute charging in the flight training industry. The flight schools tell us as long as it's less than 30 minutes, we are happy. So we have the right kind of batteries today. We do not need to create new technology. So we have very low technological risk because the engine is already certified by Safran, a French company, and we are about to see the certification of the battery packs in the United States as well. So we're very excited that this aircraft can be integrated very simply into fleets. We have a charter company in the United States on the East Coast that flies people in the summer on vacation from New York and Boston to Nantucket Island, Martha's Vineyard, which you may have heard of. And this company, which advertises our aircraft in New York Times up on the big billboards, we're very gracious for that. But he told me, Rod, the number one reason I want your aircraft is that I can simply replace and substitute it for my other aircraft. I don't need new runways or taxiways, no new hangars, no new airspace, no new pilot rules, no new maintenance rules. There will be differences, but we don't need new rules for it. So he said, I'm happy because I can simply substitute it. Now, of course, he has to build some additional electrical capacity to his flight school and add some chargers. But even then, the way we have developed it and working with charging companies, we believe we only need one charger for every 6 aircraft. So the relative cost per aircraft remains relatively low. So what's really important to flight schools and again, as I mentioned, how we can disrupt their operations, is by driving their operating costs down 80% while having a somewhat similar price point for the aircraft going to the market. Yes, a $645,000 aircraft seems expensive, but that's what Cessna aircraft are being sold for. And Cirrus aircraft are even more by several $100,000. So we believe we have a similar price point for purchasing, but the drastic drop is in the operating costs. So we did an exercise where I did an analysis of a flight school that hypothetically has 15, let's say, Cessna aircraft. If we were to replace those 15 Cessna aircraft with 15 E-Flyer aircraft, we would drop their operating costs by approximately $1.8 million. This is on a $9 million annual revenue company. So you can imagine $1.8 million being saved on a $9 million revenue company. That's drastic in a good way. However, because the aircraft E-Flyer is also much more simply designed, built, and manufactured. It has about 1/3 the parts of most legacy aircraft. It has very strong composite structural parts. The engine and propulsion system is very simple. By reducing the maintenance requirements and the downtime to do the inspections, aircraft have to be inspected every 100 hours, and it usually takes 3 days. These aircraft will go through inspection much faster. So flight schools will be able to use our aircraft approximately 10% more than legacy aircraft. So that is an opportunity for flight schools to add more revenue to their bottom line. So for this 15 aircraft flight school with $9 million in revenue, an average of $100,000 in pilot training, at least in the United States, that's an average, which is very verifiable through Google searches. We not only drop $1.8 million down because of the reduced operating costs, we can add another $200,000 in opportunity revenue because of increased availability of the aircraft. So we can drop $2 million to the bottom line, which in our calculations with flight schools, at most have an average of about a 10% EBITDA and typically run a lot less. But if I'm being generous and give them a 10% EBITDA average, we will be able to at least double and most likely triple their EBITDA returns on a day-to-day, on a year-to-year basis. So this economically disrupts the flight school industry in a good way and also creates the opportunity for the flight schools to pass on those lower costs in terms of lower tuition and flight costs to the students, therefore increasing the access for the students and hopefully being able to better populate the cockpits of the transatlantic and intercountry flights that we see day to day. So this is a rising tide for all boats, in this case aircraft, if you will, and that's why we're very excited about it. There's an old notion that no man is an island to himself, said by a famous author whose name I can't recall. But we know that in success in companies isn't from one person. On sports teams, it isn't one person, it's the team. And so our team consists not only of our internal team, but our partners like Amprius Technologies, like Safran, a very well-known name in aviation based in Paris, France, who just received the world's first ever certification of an electric engine. And that's our partner. When I was introduced to the global CEO of Safran 2 years ago at the Paris Air Show, I was introduced as the most important, our company was introduced as the most important relationship in aviation for electric propulsion. That was quite a compliment, but that's the potential they see in our company. We use Garmin avionics, which people probably know that name from wearables as well as in automotive products, but especially in aviation. I can't overstate the importance of Siemens digital industry software. I know people here in Taiwan very much recognize the value of high technology. Being able to create a digital twin, which is what we've done through their investment in us, allows us to quickly make changes in certification that save millions of dollars and months of time. It allows us to create new options for customers with the same aircraft. It allows us to make an E-Flyer 4, which is the same aircraft, just a little bit larger cockpit. That'll save tens of millions of investment and capital, as well as many months of time. And beyond that, the Siemens software not only aids in the design by creating this digital twin and the, if you will, fluid dynamic, computational dynamics, and the analysis of how many layers of composites need to go in. It's that detailed. It also can model and create a digital twin of our entire manufacturing process. So we can not only do a digital twin of our plane, our products, but of our entire manufacturing and production process. That is extraordinarily powerful. Because what that means is, as the company, as far as we know, we're the only company building aircraft or desiring to build aircraft of this size that would be incorporating this type of software across the entire enterprise. That gives us the potential to become and sustain our leadership in the industry. So that's the kind of partners that we keep. So finally, timing and investment. So as I've mentioned before, we see, looking at the bottom line, we have approximately 24 months with a $50 million investment that will take us through the rest of the certification process. This is about 1/20th the amount of investment that some of the better known electric vertical takeoff and landing companies have in terms of their raises. So it's a relatively very, very small number. It takes us through not only certification, but also our production facilities buildup, bringing in all the tooling, and being able to work up towards 1,000 aircraft per year. We believe that $50 million in equity would be matched with $25 million of non-dilutive debt funding. We have worked very closely with the Export-Import Bank of the United States, which is a very, very stable entity even with this current U.S. administration, because they provide loans to companies to create U.S. jobs and to export the aircraft. And our company, as I will show you next, of the 1,024 deposits we have, approximately 45% go to international customers. So our product has a global interest. So from the financial summary, we have about 2 years until certification, and then as you can see through the 6 years of production, we aim to get upwards of over 1,000 aircraft per year. We know this is doable because Cirrus has done it in the last 10 years or so. Cessna, in the 1970s, I believe, was producing 10,000 aircraft a year. So we know it's doable. It's not easy. It will be lots of hard work, but we believe it's achievable, especially with the assistance of, again, the digital enterprise twin that we would do with Siemens software. You can see with the revenue, by production year 5, we are roughly a $1 billion revenue company. The numbers on the right I've mentioned before in terms of deposits, letters of intent, over 1,000 aircraft, and the distribution of where they're going, as you can see, they're very well distributed between all the different continents. So, before I leave you with a video, I'd really like to reemphasize 4 main points. One is that we have a clearly defined market and one that we are hyper-laser focused on. Number 2, we believe we have a product that can disrupt that market by lowering operating costs by 80% and bringing in lower noise, less maintenance, and no carbon emissions. We believe we have a clear path to certification with the work we've done with the FAA and with the relatively straightforward path to the rest of the certification of that first aircraft. And finally, we believe that we have leadership from the market that understands the market and that has been validated by the market with the 3-year, $700 million backlog. So with that, I am going to play you a video, And this is from an investor event that Dr. Kang attended in January. It'll give you some insight, some visual insight as to our hangar facilities in Colorado, so that you can see it's not just two-dimensional graphics. There are real production people and aircraft in work. And so bear with me while I do that. In the meantime, I would recommend, if you have further interest, of course we'll talk more today, but the primary point of contact is Mr. Jim Dunn, our CFO, and there is his contact information.
Why do we need an electric airplane?
Anywhere you go, you see the airports are more and more filled with folks like us who want to go travel. And so that demands a large number of aircraft that need to move these people around. And that growing demand creates a demand for the pilots, and of course they need training. Boeing, they forecast the need for 30,000 new pilots every year for the next 10 years, which is an incredible amount of training that needs to be done. Well, those pilots get their training currently in an international training fleet of about 18,000 aircraft. The average age of that fleet globally is 45 to 50 years old. Our current providers of aircraft, Cessna, Cirrus, Diamond, and Piper, they're only producing about 800 aircraft a year when we need 2,000 to 3,000 a year. So there's a giant demand and a growing demand that we forecast for the next several decades.
It's a national infrastructure problem, it's a security issue, and one of the big questions is, where are the planes going to come from? You know, if this were available, it's not only the availability of a new type of aircraft, but our operating costs are expensive. And quite honestly, you know, the technology needs to keep up with student expectations and where the industry is, and also addressing some of the needs of airports and neighborhoods. That all, you know, fits right into the investment thesis behind this technology.
The combination of electric with a new design technology that's emerging against a market that needs new pilots was the vision for how it was birthed. But it wasn't a retrofit on an old airplane. It demanded an entirely new design.
We're going to go from almost zero to 1,000 planes a year within 5 years. There's less than 3,000 parts. This is built to be manufactured. In the electric aviation world, we need somebody to be successful, and we're well positioned to be that. We're simple, we know our market, we have leadership from that market, and that's what makes us different.
This company led the industry globally in getting the first agency, which is the FAA, to accept electric propulsion in 2018. We helped write those rules. We know the market we want to disrupt. We have the leadership and a product that is going to disrupt that market through economically changing the ballgame with 80% less costs. We have established and have traveled down the regulatory path to remove those obstacles and de-risk the regulatory aspect of what we're aiming to do. In 2025, we have a pathway to have the first all-electrically propelled Part 23 aircraft to take flight. Okay, so thank you. So last thing I want to say is thank you very much for your time this morning. Some of the things we didn't address in the formal presentation or in the video is that we, in our investment thesis, are looking for a lead investor of $10 to $15 million to get us started, and we need about $5 million in the short term to help us take what you've seen in the video, to help us get the structure finalized, get it integrated with systems, and get the first airplane in the air. One of the most important milestones in an aviation manufacturing company is to get an aircraft literally in the air. So we are very close. We're within $3 to $5 million of getting an airplane in the air. And our customers tell us we will double to triple the order book if you get an airplane in the air soon. We have many secondary investors who will follow that we have lined. So we're looking for a lead investor or those to partner as a group, which would be extraordinarily a huge catalyst for us and transformational. Beyond that, we, as you can probably guess, would like to start our manufacturing in the United States. However, we are very open to discussing with those around the world because we see this as a globally needed product. There are plenty of opportunities that we see to look at partnerships with manufacturing firms, whether it be for battery packs to incorporate battery pouches, up to an FAA standard of safety, to look at composite fabrication, or perhaps building kits like for the cockpit or certain parts of the aircraft. So we're open to those types of discussions because, as I mentioned before, we're looking for globally leading partners, some of which I've mentioned already. So we know there are those caliber of companies here in Taiwan, and that's why I'm very excited to be here with you today. So once again, I want to say thank you to William and the team for hosting us. Thank you for Dr. Kang for helping be the motivation behind all this. And I thank you all very, very much for allowing me to spend part of my day with you on your very important week. So thank you. I'm happy to take any questions now, and then once we break, I will be happy to discuss with you. And Brennan, my associate here, Brendan Minkoff, is part of our business development team. He adds a lot of youth and energy to our team, and he is very, very, I would say he is our primary point of contact for any flight schools or potential customers. He would be best equipped to speak with you today. So again, thank you very much, and I'm happy to take any questions.
各位贵宾，如果有任何的问题都可以现在提出来。那待会应该今天比较早讲完，待会还有很多时间，大家可以互相交流。我们这边有很多我们台湾的科技产业啊，各方面的这个先进啊与精英啊，大家都可以做个交流。如果请说，您前面有一个那个麦克风可以按。
Or if you want, you can just convey your question, then I'll repeat it for everyone.
I'll be loud. I'll try to be loud.
Very good.
Yeah. Okay. Thank you. So I saw your list of strategic partners.
Yes.
Those that support parts and components, software, all that. So for the assembly, you mentioned you want it done in the U.S., but do you have a site organized, or are you here to look for partners on that as well?
Okay. Did everybody hear the question? The question was, have we decided on a particular site, or are we open to other sites for fabrication and assembly? So for folks who know, for companies that are in the manufacturing space, depending on the nature of the industry, especially in the aircraft fabrication assembly, lower labor costs are the principal driver of this type of industry. So we have been on the lookout in the United States. I would say we have a prioritized list. We have not made a final decision in the United States, but we also have not made any final decisions on whether a particular site in the United States would have 100% of the fabrication and assembly. So there's room to discuss different strategies on this. And two, because we believe the Asia-Pacific region will be a robust region of sales for us, I can see opportunities to have fabrication and assembly, or maybe just final assembly here in the region. So we are very open to those discussions. I hope that answered your question. Thank you. Yes, sir.
This is Justin from Lion Technology. So I'm curious about since you want to charge your aircraft in 30 minutes. I'm thinking about a scenario if there are lots of airplane waiting, stay in line to charge your battery. What is any particular strategy to streamline the charging status?
Oh, very great. The question is about what is our strategy on charging?
Yeah.
In practical day-to-day operations.
Yeah, you make it more efficient. Yeah.
Yes, that's a great question. Thank you very much, sir. We are engaged in discussions with several different types of charging companies. For aviation, the planes are operated out of airports, and the airports have different restrictions and geographic dimensions than putting a charging station next to a road, of course, or at what we call now a gas station, but now would become a charging station, right? So for aircraft, What we are looking at, one company, we're principally seeing two approaches that we think are smart. One is a charger that's basically on wheels that's retractable from, let's say, a hanger or a fence line that can be pulled out 75, let's say 25 meters or 75 feet, something like this, then has two cables to charge two aircraft simultaneously. And that type of scenario, that way the aircraft doesn't have to just have one aircraft there. We can charge two aircraft at once. And if they're charging less than 30 minutes, those first two aircraft can go fly. Two more can charge for 30 minutes. They go fly. A fifth and sixth aircraft charge for 30 minutes. They go fly. And by that time, 1.5 hours later, the first two aircraft come back. So you can see through that repetitive cycle, only one charger is needed for 6 aircraft. And at the end of the day, all those cables then are retracted, the two cables are retracted into the center charger, which is then retracted back to the wall or to the fence of the flight school. Yes, we would use commercially available charging technology. We see that the fixed charging stations that I've not traveled enough here in country to know how they're set up, but in France where I've been, and in the United States where you see fixed charging stations, those seem to me to be difficult to implement because it restricts the aircraft to having come close to the fence or inside the hangar. The other technique that we know of, at least in one case, one of the U.S.'s largest flight schools, which is building a new location at the same airport for their new campus. They're building what are called sunshades, sun shelters. The aircraft come in, they're parked below, and then there's shade over the top. Well, the posts that hold up the shade, they have equipped them with the cabling so they drop down the cables and can charge once they're parked in those sunshades. So that's an innovative solution as well.
Yeah, thank you.
I would add just a little bit. One thing we toyed around with would a charging truck, just like a fuel truck, would those be viable? We're having a hard time making the numbers work because when one does the analysis, an aircraft like ours, the battery pack is about the same as in a Tesla Y, about 90 kilowatt hours. All right? In a typical training mission, the pilot might use half of that, about 45 kilowatt hours. So if you add up 5 flights a day times 10 aircraft, that's a lot of capacity that has to be brought into a truck, batteries, which are the only, so you're charging the batteries in the truck, but then you're transferring that to the batteries of an aircraft. So you're wearing out the batteries in the truck really fast, so it becomes one, the truck is very heavy because of the battery weight, and 2, it can become relatively expensive. If a third party can come up with a great idea, if someone's brilliant in the room and can figure that out, we'd love to talk to you.
Yeah, that's why I am there.
Yes, sir.
What do you expect the rental rate would be per hour for this aircraft?
When do you expect the aircraft?
Yeah, the rental rate. Rental.
The rental?
Yeah.
In terms of the price, you mean? Or?
Because if somebody operates this school, usually would rent the aircraft.
Yes. So if I'm understanding your question, sir, is we have aircraft deposits from flight schools themselves, but also from leasing companies. So we see a big trend in that flight schools are having an increasingly difficult time affording the high price of the aircraft, the purchase price. Mm-hmm. So we are seeing more and more interest from leasing companies to acquire large numbers of our aircraft and lease those.
Yeah.
Because I can only speak for my fellow countrymen, but a lot of people can't pay a high cost of a house with cash.
Right.
But they can afford a house payment, a monthly house payment, or like a car payment. Mm-hmm. Similar, we see this happening in the aviation world.
Right. So what do you think the rental rate would be, roughly?
The
rental per hour. If the
baseline cost is $35 an hour, and then you factor in the purchase cost, I would still say it's going to be somewhere between maybe $70 $85 an
So
hour.
it's competitive to the current
Very
rental rate for the
competitive,
current airplane.
yes.
Yeah.
Because, again, for the leasing companies, the purchase price is, at least by U.S. tax law, it's depreciable and you can amortize it over years. So that capital cost gets recovered through tax deductions, for example. So we see there's going to be a lot of interest, I think, in the leasing. Yes, sir. Any more questions? You don't have to be shy.
So how fast do these things depreciate? Because you're taking off at a really high C rate. You're also charging it at 2C. Like what is the lifespan that you're expecting on most of these planes?
So I'll address that in two ways. One is what we call the energy storage system, the ESS, the battery packs. I'll talk about those lifespans, and then for the aircraft itself. So for the battery pack as a whole, depending on the modules, I won't go into the numbers, but we expect a 4 to 6 year life cycle in terms of depending on the usage rate by a flight school. So it's not every year, not just every 2 years, but we're seeing in practice, and you can read it, you may have seen some of these online. Tesla is finding out, for example, with their batteries, when they did testing, they said, here's about how many cycles we're going to have. But in reality, the variation in methods of charging, depending on how much, how fast, it's actually leading to much longer battery life, which is really interesting, and we're very happy about that, rather than the other way around. So we see that the replacement rate would be 4 to 6 years, and that $35 per hour includes the battery replacement cost as a set-aside in that cost as well. So just like with Cessna, when we talk about $160 an hour to operate a Cessna 172, that includes the replacement cost to refurbish the engine, the propeller, all that stuff. So we take an exactly parallel approach in the sense of our engine, which won't need to be replaced, we don't know how long. Safran doesn't know. It could be 10 years, it could be 15 years, it could be 20 years. They don't know it because they've just created these engines. And as we know, electric engines are extraordinarily durable. They only have one moving part. And so they can last a long time. So we don't have to have the engine set-aside costs going to factor into the hourly cost. So just the batteries do. So that's probably 1/3 of that $35 per hour is the battery replacement cost. With regards to the whole aircraft, because it's made of composite materials, and I know very well from flying F-15s not too far away in Okinawa, that this air is very corrosive because of the salt in it from the sea. And so this aircraft being made, its structure, 225 parts are all composite. I have some photos I can show you. We're literally fabricating the main spar at our headquarters as we speak. It should be finished today or tomorrow, which is really, it may not sound exciting, but to someone who's making the airplane, it's really exciting. It's the most important part of the whole airplane. And we're about to have that done today or tomorrow. And these will have indefinite lifespan. They will not corrode. So only unless they're literally damaged by some means, the aircraft itself will retain its value, we believe, very high. And what's really interesting with replacing the battery packs, unlike in today's paradigm of refurbishing the engines every 2 years to 3 years for flight schools, you get the same engine back. No better performance, hopefully no worse, but it should be the status quo. But in the future, if you can imagine, and Dr. Kang knows this far better than I, the cost of the batteries by any metric and or the capabilities of the battery, those continue to improve. So the curves are coming down. Now they may be leveling off somewhat. There may not be as steep a curve, but we, for the first time in aviation, will be able to, every 5 years, have the same aircraft either have a lower operating cost or a lower cost of the same batteries, or have an option to have improved batteries with longer duration. And as we know from whether it be our personal telecommunication devices, or electric vehicles, and aviation so too, we're going to have continued improved battery performance over time. So it will make the value of these aircraft actually increase relative to their legacy counterparts, which theirs have been some increases too due to demand, but for most of them, Piper and Cessna, they're all aluminum aircraft. They're going to corrode, they do corrode, and there's real issues with those, so we do not have those here. With the batteries, we believe we'll be able to have, Dr. Kang, I'm sure, will assure me and all of us that we're going to have better performing batteries every 5 years. I'm sure of it. That's the way the industry's been going. So we're excited about that. So thank you for your question. That's a great one. Do we have cybersecurity issues for charging?
Usually we will put a middle layer in between the cloud and the edge device, or the component or charging device. So that's where how we do this to deal with the cybersecurity issue. Yeah, that's.
Yeah, I can't speak to the specific coding technologies, but one, we will code our aircraft uniquely to be able to talk with the charger and with the charging companies. Because it's such a small number relative, like for example, in the United States, I think the previous administration had funded 500,000 chargers or something like this, stations around the United States. And there'll be many more, there would ideally probably, excuse me, maybe millions of them. But for aviation in the United States, we have maybe 5,000 airports that could be used. We have only maybe, because of their fleet size customers, it's only in the dozens of customers initially. So I think we'll be able to limit the exposure, the risk, because if we're working with that one company or two companies, for example, I think we can limit that exposure for a cybersecure charge until we get into more public use at airports.
Oh, yeah.
Then that has to be thought of for sure.
Yeah. Because the reason I raised this question is that it's pretty it's a big deal in the commercial electrical bus charging station, especially for the charging free. Yeah. So the hacker can hijack the whole free. So that's why, especially in the U.S. So
we will be sure to incorporate international standards, and I'm sure our U.S. government will have something to say about cybersecurity as well, so that we are compliant. So thank you. It's a very important question, and I appreciate you bringing that up. That's something we will take a harder look at. Thank you.
我认识 Rod 很久了，这个公司，我个人来讲都很有兴趣。为什么呢？是个投资的机会。看这个公司，当然这个每个具体部分都很重要。那最重要的是什么？最重要就是说，现在这个在美国至少他刚才也说了，现在需要3万飞行员每一年，下边这10年，这个不是他的估计，这是联合航空United Airlines 的 estimate。所以在现在美国最重要的就是他这个训练，这个 training school 在美国，所以现在就有这个大概1000个这个这叫什么？就培养飞行员的这种学校。他现在又面临几个问题，我对他这个公司研究很久了，跟他好久，所以才决定帮他们做电池。第一个就是这些飞机都很老了，刚才他说45年，平均年龄45年。第二个的话就。现在在美国要接受一个训练，比如今天我想去做飞行员，我这个成本不是一般人能够承受的，所以他这个第一点就是说，他想怎么样子把这个成本降下来。开始做这个生意的时候，不是说我们有一个非常 sexy 的这个新技术搞一个非常漂亮的飞机，不是这个意思。意思就是说我怎么拿到这笔生意，这么大这个生意，这只是在美国，人家到欧洲那问题更严重。前一阵我在比利时，从比利时看欧盟，那问题更严重。所以如果谁能够把这个训练飞机这个成本这个整个训练的这个成本降下来，也许他就得到这个生意。那得到这个生意，那就是好的投资机会。所以我们看这个呢是从投资机会来看的，并不是从技术上来看。那么他现在的这个从纸上算他还没有真正的全部都证实到。从纸上来算，它现在可以降低成本80%。他刚才也说了。 80%是什么个概念呢？80%你就把整个市场都拿下来了。而且还有一点，他对我个人非常有兴趣的，就是说他现在已经拿到了900架飞机的订单。那对我有兴趣有2点，第一点就是这个也许是个很好的投资机会，今天投资它，也许明天就是个不一样的收获。第二点的话，对我们卖电池的，这也是很了不得事。他这个一个飞机装的电池比汽车要大多了，对吧？而且我还可以卖给他高一点的价钱，啊，所以说这个公司呢，对我们是很有吸引力的。这次来呢，就是说他这个前续的工作都做了。这次来台湾，我们会到台湾，明天去香港。在美国、在欧洲都在考台湾，这是第一次了。我建议他来了，因为我在90几年的时候，我在台湾赚了不少钱。那时候做 LED， 然后又做这个 scanner， 所以我台湾很多的这个早期的这些公司我都投资的，而且台湾这方面的发展都很，只要台湾做，那一定能成功。所以我就同他说，你不要只考虑到融资，对吧？融资是一部分。我们在台湾如果能够做飞机。如果能够做我们电池包的组装，对我来说，我们已经威廉介绍，我们已经同台湾一起这个 pack 厂，已经在有合作了，也可以把它这个电池拿来合作，那 pack 厂也可以投资它，要做 strategic investors，所以他这次来的目的呢，就是说，他总的来说就是他把这个生意整个做起来。他花的钱跟那个 eVTOL 啊，你知道这个什么 R 比了，什么 Joe 比了，Archer 了，跟这些比，他只需要他的1/5的钱，他就可以把这个生意做起来了。这也是他吸引人的地方。当然，他是 fixed wing 啊，你看他这个飞机翅膀不是螺旋桨型的，它不是直接上下的，对吧？但是他这个飞机的设计，现在刚才看了一堆这个战略合作厂商嘛。这个都是精挑细选，在前面这么多年挑出来的，所以成功的几率是在。我这次鼓励他到台湾来，就是几点：一个，看看台湾有没有兴趣的投资人；第二个，台湾有没有兴趣的战略合作厂商，愿意帮他做飞机的，愿意帮他做这个电池 pack 的，甚至于如果台湾有什么这个可以做零部件的，也可以参与。他第一步想做的就是能融资500万。500万美金，这是他第一步的融资。实际上这个是很小的钱了，一个人就可以给他了，但是呢，他就是这是他第一步。第二步的话，就是他想融资5000万美金。这5000万美金呢，就是他就把这个飞机啊就可以，他就有一批飞机可以飞上去了，所以这就是今天这个我们做这么一个简单的论坛的一个目的，如果对投资有兴趣，对合作有兴趣，都可以跟他们交流。他现在最吸引我的这个和我们公司我也不想在那里浪费时间，对吧？花了时间帮他做到最后他不成，做这个电池还是蛮花成本的，特别他这个电池又特别大，所以就是同他今天有兴趣合作的，比如愿意做 pack 的，愿意在飞机组装上有兴趣的，愿意提供他材料技术的，愿意提供他技术的，那最重要的愿意投资他的，那都可以跟他做交流。好，谢谢。
好，那我想我们今天的论坛大概就到此结束哈。那其实我们这边还可以到12点，其实大家可以私底下有很多时间可以交流哦。那我相信现场有很多的供应商，各个方面的这个科技的公司，或是一些投资方，当然也有这个飞行训练学校的哦，待会都可以交流。